In this study, a model was developed to evaluate the economic value of the health and climate benefits of reducing fossil fuel consumption by employing different low-carbon energy projects. The model was then used to simulate 4 different types of projects individually at 6 different locations in the Great Lakes Mid-Atlantic region of the U.S. In these simulations, both the type of low-carbon alternative and its location strongly affected its impact on human health and the climate, important considerations for policymakers, especially those working under President Obama's Clean Power Plan. For the 6 studied locations, these projects could provide health and climate benefits worth up to $210 million annually and up to $170 per megawatt hour of electricity generated. To reduce emissions of greenhouse gases, electrical utility companies can turn to energy efficiency strategies, which can displace fossil fuel use by decreasing the demand for electricity, and also renewable energy sources, which can displace fossil fuel use by substituting more environmentally friendly options. This study modeled the effects of 2 renewable energy installations, a wind power plant and a solar photovoltaic installation, and 2 energy efficiency projects, one that reduced the electricity use at peak demand times, and another that reduced electricity use at all times. The 6 locations covered a variety of population distributions, electricity requirements, power grid conditions, and electricity generation capabilities. The researchers then calculated the changes in the emissions of CO2, SO2, and NOx for each low-carbon energy project, and calculated the benefits of each project based on the estimated damage induced per amount of emissions. All the installations in the simulation reduced the electrical grid's overall emissions and therefore its impact on human health and the climate. However, the locations with the greatest health and climate benefits were not necessarily those where the new installation saved or replaced the most energy. Instead, the benefits of the projects varied by installation type and location, even when adjusted for the amount of electricity generated. For example, the wind installation near Cincinnati was twice as beneficial as the one in Virginia, not only because the wind installation near Cincinnati displaced more coal, but also because Cincinnati has a larger population downwind of its coal plants. Meanwhile, the solar installation near Cincinnati was nearly 3 times as beneficial as the one near much larger Chicago, because it displaced much more coal. In the future, the model in this study may be used to predict the benefits of other low-carbon energy projects in different parts of the world. The specific findings of this study may also be useful for planning new low-carbon projects within the Great Lakes Mid-Atlantic area, particularly in the wake of the Clean Power Plan, which requires policymakers to devise plans for meeting state-specific goals for reducing carbon dioxide emissions.